Hey guys, how's it going? So let's do a little bit more fault detection and diagnostics reporting today in our Vibe Code App 19. Reference the previous videos if you want to see what it's a Python application. It's a Streamlit application. So that's like a data analyst or data scientist dashboarding application. So kind of reference the previous video if you want to get a little bit more detail on um, what Streamlit is, and it's really good for prototyping. And also on Open-FDD, the rules that we're prototyping with will live in Open-FDD. Join the Discord if you want to. Um, then also, like, here's the Open-FDD GitHub docs online. Go down to the rule cookbook, and what we covered yesterday is the Python rules for fault detection and analytics are written in pandas. That's a Python computing library that very popular for analysts, and every modern data science project most likely has pandas involved somewhere in the application, though it's not a math library for like machine learning or anything like that. It's it's mostly used for data wrangling and data manipulating, data cleaning, and it's also really good for tabular data sets. So kind of think of it as like the computer in memory, like a big Excel spreadsheet, and we can run very much more efficiently than in Excel all these tabular rules for fault detection. So that's what the Streamlit application is using pretty extensively. Um, then the future Open-FDD application that is going extremely slow is getting rewritten in Rust, and that'll be part of it'll use data fusion SQL. So like we talked about this a bit in the past, is like you can get the same results from rule-based fault detection as you could in SQL. So what I'm shooting for is kind of prototyping in Python and Pandas, and then even right in this present moment, I'm rewriting the Streamlit application in Rust. And okay, so basically, this is a little bit of the AI engineering stuff, loop engineering. So I think like ChatGPT is really, really good at prompting, prompting for other AI agents to code. So I'm doing all of my loop engineering in by ChatGPT, and there's not much to it. Like what I'm basically doing is going to the Python BACnet 6 playground, copy in a link, put it right into ChatGPT, and then I need to rewrite this all in Rust. And also part of this Vibe Code App 19 is there is a AI a software engineering specification for AI agents that's blessed by Fable, the most famous new model out at the moment. So there is basically you can feed this right into AI, and I encourage other people to play around with this too. Is basically it's a template for how other AI agents can kind of run with it. I'm using this too, converting this right over to Rust, Data Fusion SQL. All right, I have a feeling there'll be like a few more iterations on this Vibe Code App 19. Like I want to, I think I might be able to find one person that has like a SQL server running for their HVAC data lake. So I at least want to get to this Vibe Code App 19 that it can build Pandas data frames. So the Pandas computing library, you can ingest data via CSV from SQL, and there's a couple other different data sources. So I just want to get this app up to the point where it can crunch some numbers on a few different data sources. And yeah, so that's like you can just feed in download copy a link, put it right into your AI agents, and that's kind of like one of the latest and greatest things. It's like um, AI can just surf the internet, do whatever you want to, whatever you need it to do. And another bonus on my end is that Open-FDD is open source. So what I'm basically doing is kind of keeping track of, um, so the agents are responsible for um, writing Git issues, and then it's also maintains its own tasks and pull requests and everything. So it's updating the Python code to Rust and Data Fusion, which Data Fusion is a Rust native project by Apache, by the Apache Foundation. Um, so like basically, I'm just until I get to the point until like the AI agents can give me like a workable web app that I can dial into, and then kind of check it out, do some web app testing. I'm just kind of having it, I iterate until it can recreate the Streamlit application in Rust and in React as well. It's a front end library. So porting it over to just a more production code base versus just a data science web app dashboard. So that's kind of like something else I'm working on, and I can't wait to show you guys this in the future too. So like I'm just asking ChatGPT, please check in with the agent status, where we are at project, have them clean up the GitHub issues and keep continuing. Make me another monster loop. And that's usually like good enough. In I think I will have something soon here that I'll at least have like a web app. It'll probably just be like something kind of mimicking the Streamlit application. Um, and that's kind of what I'm after. So it's kind of like that is a little bit of like the AI engineering. If you look at some of like, so like on the Python BACnet Stacks Playground on GitHub, I'm just going to show you the Discord. So join the Discord. So like we post latest and greatest in AI stories, all the time. I post my videos here too. So if anyone wants to post their videos, but even Tech with Tim, on how to go from software engineer to AI engineer. This is kind of like part of an AI engineer skill set, is kind of porting it over from concept idea to production. Even though this Streamlit application in Python for Open-FDD vibe code is fully capable of being some kind of a production um, data science web app, kind of uh, application. And it's even, you could even build a login for it if you wanted to have it sit out on the internet. So that's something I could also demonstrate as well. So, okay, so I haven't been getting into the fault detection part of this, but I just want to keep my AI agents coding Open-FDD and converting it from Python to Rust to kind of keep them going. So this is, there's no way that I could write this monster prompt like this. It's, I've been doing this for about a month now. It's like just using ChatGPT to make massive loops for the AI agent to I iterate. It can be hours at a time. And I had the AI agent watches the GitHub issues, GitHub actions to make sure GitHub actions pass. There's software engineering tests called unit tests. Um, yeah, so see where it got us. Okay, so I think it's getting close. Wow. This is just hundreds and hundreds of lines long. But I don't think there's any way. So people that are saying like the latest and greatest thing is to do loop engineering and not prompting, but I think like there's no way that you can get around just uh, loop engineering. Okay, so I have like two instances of cursor open, one with the font really big, because that's the one I want to demo today, and then this is really small, and just so I don't get the two mixed up when I'm kind of going in between. So I just gave the cursor agents working in Windows subsystem for Linux to keep on iterating, converting the Vibe code app 19 to Rust. And this will probably be going on, I have a feeling, for who knows, probably forever. But as soon as this gets to a working prototype, I will demo this as well. Okay, so these guys will probably be good for probably a couple hours. So I'll probably check back with them before I go home for the day, and then give them another one to work on, all night long, if so be it. And just another thing, so like at the time of writing this, cursor models. I like cursor. Some people like Claude because I think they all do the same thing. Just personal preference. So like default cursor settings are Grok. This guy's even 50% off. Composer, which is a really cheap model to use. Opus 4.8. Soul, it's in there. Fable 5, Sonnet 5, and GPT 5.6 Terra. So these are Soul and Terra are from the same OpenAI family. So I just keep on going in auto mode. And whatever it's doing, it seems to be working. And I am not burning through tons of credits. So it's whatever they have going on under the scenes in auto mode seems to be good enough for me. I also have this generic thing that I might even queue the AI agents is to, because it seems like there's always some unfinished tasks on a pull request or something. So this is something just generic, is for unfinished PR work. Fable 5, please create a concise plan to repair. Soul, please critique and improve that. And then go back into an auto mode and keep going. So maybe I'll just plop this one into the other one down here. Plop you in. Okay, so this is hard to see, guys. It's on really small font, but down here, this is just a queued prompt that as soon as these guys finish up, more than likely there's some unfinished business. There always seems to be. And if there is, Fable 5 will write a plan to just keep continuing, else it'll just, pass. And it seems to be working. Good enough for me, at least. Okay, so like, let's get back to this Liberty Building 100. Trying to think where I should go with this. So like, I do have some updates to show you on this. Okay, so like, here we are. I'm going to close out of this. Back into the Python BACnet Stacks Playground, Vibe code app 19. Let's just get to the main place on here. Streamlit agents markdown file, which then you just aim your AI agent at that. But if you're just experimenting with this application, you should be able to just do it in Docker yourself. I don't even do this. So this is like what AI agent does is it just runs the Streamlit application in development mode. And then I'm pushing to the GitHub container repository their images for Docker images. Okay, so here we go. This is just, let's just run this. Okay, so I'm going to use PowerShell here. And like I said yesterday, check yesterday's video for downloading, if you're on Windows, it is the Windows terminal. excuse me. Now, this is a really powerful Windows subsystem. Just use this. Um, don't use ordinary command line or PowerShell. I think this is a really powerful tool. Makes it look just like the Linux made by Microsoft and everything. So, okay, so let's just, I'm just going to SSH into my little, my old Windows desktop that's converted to Ubuntu server. So there's no desktop environment on this Linux instance. Let's see, Docker PS. So I should be able to just pull this latest image. So this bash command, which will dump in here, which will pull the latest Docker image published for Vibecode F19. And then it will just run it. And there's also some flags that you can ask. You can do this -D afterwards, and that'll stay up and running permanently. So a couple other things like we also have to dial into it on port 8502. You can give it different names. So like, a couple different things. You can just aim. You can even ask ChatGPT to, help me make me a tutorial for doing this too. Sometimes I do that as well. Yeah, so like if you're this app is maybe getting to the point where, let's say you're a sustainability manager for a school district or for some campus higher education buildings or something like that. You could have your IT department spin up a little Ubuntu virtual machine or something like that, and then they could do all these same commands too. And then they would just basically let you do a -D. Is it would the application stays running by Docker long term. Because when I just run this, as soon as I close this SSH section, it will kill the web app too. But you just do the -D to keep the web app running for the long haul. All right, so now it's pulling the latest and greatest Docker containers. There's also ones published for Raspberry Pi ARM architecture too, which I think will work on Mac as well. So there's basically Windows, x86, and then there's ARM. Full complete. Okay, so I think that we have this guy running. Should be able to just dial into it. So I'm just dialing into my, I'm basically just dialing into this guy right here. This guy is hosting the web app for me through Docker. And so yeah, so hopefully that makes sense. The Docker commands I just ran were SSH into this guy, which could be a Raspberry Pi, which could be a virtual machine hosted by your IT department, which could be, it could be, anything you want it to be. It could even be, I have Docker desktop on my computer too. So a whole bunch of variety, different ways to do this. Okay, so like, I'm just going to keep on going with this building 100. Let me just get to these zip files real quick. Okay, so 1 second, guys. Sorry. So here they are, 2 zip files, building 100 and weather. Weather data came from openmedio.com. Not .com. It's a weather API. We talked about this previously. So I downloaded local weather station data from OpenMedio. There's also some requirements in here. Is that let me show this next. Of course, now I have to get back to it. You see this little um, guy up here, the triathlon guy. That means the web app is still crunching. So in here, I'm just gonna see if I can zoom in. Oop, I can't zoom in. So what goes on behind the scenes is I'll demonstrate this a little bit later, but there is actually a requirement of a JSON file that you feed this. So you could do this with ChatGPT or Claude or whatever running locally. Is you just there's a JSON keys and value that maps CSV file column names to haystack names. So the AI agent helps kind of mesh that data model together. And just another thing to point out, it's not really a real data model either. Like it's haystack-like. It uses um, haystack names, but I think if this was like a really full-blown data model, it would be haystack RDF, haystack, which stands for Resource Description Framework. Um, so maybe we'll do that in the future, but that's like a huge can of worms. Like if it's advanced data structures in computer science theory is the resource description framework. So I'm just using something kind of more simple, simplified version. It's just a JSON uh, keys and values mapping, where if we were doing a full blown data model by which like the PhD computer science people brought to the smart building world is like we should be using the resource description framework is called RDF. So that's something how Google and search engine that's the technology they use. It's graph based searches. So I think my data set is just too small to require something that is powerful enough to search, keywords on the internet for. Um, but if this was hundreds and hundreds and hundreds and hundreds of buildings, massive data lake or something, uh, it might make more sense. But like I think at the time being, I'm just using one CSV file and just I think a JSON file for keys and values, name mapping, matching is good enough for me at the moment. It might not be as computational efficient, but it's simple at the moment. And until like there is some kind of bottleneck, um, then I will go towards RDF. Um, but until then, I don't think it's needed. I'd be really curious if anyone out there can comment on this too. Is like when does it make sense to go RDF? Um, so keep that in mind. I also have some on the Python Backend Text Playground. There is daily mini lessons, which is coming soon for me to get to start over. But day 1 to 75, day 75, 20-minute lesson in Python and Rust. We go through just a very basic syntax and computer science theory, like level 101, and we go all the way up. The end of those daily mini lessons is RDF theory. So that is, it gets really kind of advanced, probably graduate level computer science theoretical stuff, which is RDF. So maybe someday, when time permits, I would love to um, daily mini lessons, created by AI, like we'll get up to that point of studying that stuff. But first, and maybe at that point in time, there would be some massive data lake or something that it would make sense to do that. But I just don't think the complexity of RDF at the moment, I don't think it's really required. Okay, so okay, at the moment, so the next building we do, I'll explain a little bit more of like the requirements inside these zip files. But like I was saying before, you can just aim your AI agent at you can just aim it right here and just be on my zip files that I upload, excuse me, help me make these haystack like um, these sorry, it's a column to role map in JSON, no RDF. So like you just aim your AI agent at it and it'll just make it for you. And you just include it in the PDF, and then the backend Python code parses all of that information. Okay, so which it did. Okay, so like we talked about this before. I'm beating dead horses because I've talked about this in several YouTube videos. Is this building is required to maintain 72 degrees by the tenant. So I have something 70 to 75 degrees Fahrenheit. There's also metric. And if anyone on the other side of the globe is watching this, or in Canada, please test out this metric feature here as well. There's unit tests created to switch to metric quite easily. For me, it just makes more sense in imperial units because it's the only thing I've been staring at the last 40 years. Okay, so this is zone temp high and low. 70 to 75 is kind of like what will be crunching the numbers behind the scenes for ranking zones that by percent of time that don't maintain this while the building is occupied, as defined by this generic date and time picker. Okay, so I do have to add in a Saturday requirement till 2. Okay, so people might ask, why do you have a generic date and time picker? So this is to calculate excess runtime by the building automation system configuration. So the building automation system always has a generic weekly calendar runtime as well. But what always happens is that the building operators they run into temperature control problems, and then they start changing this to like run way longer than what is required because it's an extreme weather events, and then they forget about it. And then pretty soon in mild weather seasons for months at a time, you're still running the building for hours at a time. So it's like it's having a different schedule than what is on the building automation, the requirements for your tenant leases or whatever you're doing, and which is only used to calculate analytics, that kind of thing. So that there's a difference. The building automation schedule is actually running the equipment, and then this one we're only crunching numbers with. Okay, we talked about this on the last video. Boiler, chiller plant, hours of runtime. There are, for this building, I'm actually surprised that they measure 60 degrees average in March, just in its location in Upper Midwest in Fahrenheit. Usually March is still kind of chilly. Okay, so then we talked about this in the last video. This is binning hours of runtime for the chiller system. And what we want to try and do is basically shave this off right here. Like, it would be nice to get into that the airside systems can handle below 60 degrees Fahrenheit, providing free cooling to the building as needed. And if it doesn't do that, I think that merits like a deeper dive into the mechanical system on test and balancing. Perhaps there might be a VAV box zone that is not broken components in the HVAC system. Maybe we can figure this out ourselves. And there could be space utilization changes in the building as well. So like, for example, really old schools, before there was computers, now they converted this old classroom into a computer lab or a copy room or something like that. And then all of a sudden it's way too hot in there because the original zone was never designed for the heat, cooling requirements for a computer lab. Stuff like that happens all the time. Is that the space changes, but the design for that zone is not reflected. Sometimes they have in-house carpenters that just modify the rooms and then they don't modify any of the ductwork or any of the sizing of the HVAC. Happens all the time. And then pretty soon you have to change the whole variable volume air handling unit to just serve this one room, which could be causing a whole bunch of problems. Okay, we also have this. Let's talk about this. The deviation. This is a histogram where I think this local building automation sensor, it reads warmer than what we get from data from the web. So this is just the overview dashboard. Then see these buttons right here. We can look at the data models. We talked a little bit about this yesterday. This is a fed by feeds relationship. Maybe this might need to be fixed. This needs to be fixed. Okay, so I have to start documenting this. I'm just going to open up a GitHub issue. Choose, so feds and feeds is not correct. It should be VAV box to AHU feds and feeds. And this is not showing any of that information. It's just showing fan points. It needs to be device level. Let's see if I can even copy this. I don't think I can copy this. I can download CSV. Okay, so this should be devices, not points. So like air handling unit is feeds, VAV box, blah, 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 blah. And the assumption is for these kind of simple systems like this is a large office, it's 6 floors. That one boiler system feeds everything and chiller plant feeds everything as well. So you really don't need a feeds relationship for this. The assumption is that the chiller feeds these guys, and we looked at these air handling unit BAS snips. They don't have heating coils, so the boilers feed the VAV reheats. Rules ran. I think we can go in here. Oops, it's prompting me to run all the rules. So run all of the rules. Goes, there's a little triathlon guy up top. All right, all 53 rules ran. I did actually use Fable 5 to optimize some bottlenecks in how the Streamlit application was running rules. It was going kind of slow, kind of clunky. So it is a lot faster now. And another thing to note too is like we'll play around with this, is these rules all have tuning metrics as well. So let's kind of get into this as well. Fault detection plots. Okay, so like right now I am on the device AHU. So we have these AHU, boiler, chiller plant, and VAV. And then AHUs is 2 AHUs. 50% of the mapping is covered by this. So out of the 53 rules, by the data model, 21 of them apply. Okay, so this is where you can download a session config and then also a role mapping in JSON. Maybe we could even look at this quick. So open this in VS Code. Okay, so this is like what I was, no, I do not want to update VS Code. So this is what I was saying. There's no RDF. It is just device and then point. So this is kind of what the rules require. And then it's mapped through. So this is actually the raw point name. And then this is actually how we're mapping through the rules. This is almost something I think could get cleaned up a little bit too in the future. So no RDF, it's just mapping JSON to JSON keys and values, which is probably good enough for this application. Really curious. I know there's some people that really specialize in digital twins and boiler and data models, and would love to hear your thoughts and opinions on this. Okay, so let's just get into this. Like sensor out of range. Hopefully you guys can see this. Zoom in a little bit further. So this should be, if it takes like a while to go through these videos as well, so be it. It's it can be kind of complex. So we recorded one fault down here, and I can see right here that a lot of the data read 0. So it's probably just some anomaly. Maybe the JACE or the control system was getting rebooted. There's our duct static pressure sensor. Fan was off during this period of time. So this is like a delay confirmation. So if we adjust this up, and it looks like we have another bug notification. Oop, okay, so like, where are we here? Triathlon guy is swimming, biking, and running. Just get back to where it was. Sensor range fault. That's where we were. Okay, so it should be using this this new slider right here, so you can tune your rules. Okay, so I guess I don't even see that. What the heck? All right, so we might have a few issues, like there is no fault there anymore. Okay, so these are actually just descriptions of the fault at hand, and then there's just a drop down here. something does look a little bit odd. Sorry guys, I'm bouncing around a little bit. Trying to get back to where I was, that we saw that where all the data read 0. To me, this, if it smoothed out the data, that almost seems like it's kind of not sure if I really like that. Just do rerun device rules. This is probably something that could just be rewritten just a teeny bit better. Okay, so like now we do have this back in here. So this is doing something that this might actually be a bug. So fault confirmed delay. This is supposed to be a time in minutes to act as a delay to reporting a true fault to prevent lots of false positives. But what I seem to notice is that it is smoothing out the data as well. It's just a delay, not a data smoothing feature. Okay. All right. So like what I kind of wanted to get into was looking a little more deeply at these faults. So like we talked about this yesterday, sensor ranges. Oh yeah, we also need, I thought about this yesterday too. We need faults for sensor value for mobile sensor value changes per hour for HVAC systems. I had this at one point in time, but I need to add it back in. Okay, so we're saying that we have a air handling unit 1 has a fault detection below set point. So this flags duct static pressure sensor. Supply duct static low while supply fan is at near full speed. Okay, sliders. Let's go look at our chart. So we have some faults here. Oh, supply fan, duct static pressure sensor. Okay, this might be a little bit hard to see, but this top graph right here is fan percentage. And then we're measuring some faults around here. Let's zoom in on a couple of areas. All right, so we have a fault here where you can see that this something happened here in the building. So fan, okay, so this is fan right here. It's maintaining duct static pressure, and then the fan has to go to 100% right here, and duct static pressure is dropping. And then that's when we have a fault. That's a performance issue in the mechanical system. Same thing over here, it looks like. No duct static is maintained. So this is like classic. Zoom in on this day. So when the system is off, sensor goes to 0.02 hundredths of an inch of static. Fan is 0. As fan ramps up, we can make static. So it seems like when the building probably isn't requiring a load, the variable fan maintains 1.5 inches, 1.65 inches of static, no problem. But then more than likely, so this is in April. Maybe I'll take a screenshot of this. See what happened on that day when we get to the chiller. More than likely late in the afternoon. So this is 1800 hours. So yeah, very late in the afternoon. That more than likely the building is just requires cooling, and perhaps the chiller wasn't running yet. And when the VAV system, when the air dampers and the duct system start opening up because they need more cooling, duct static pressure drops, fan attempts to go up to full speed, and it can just not maintain that static pressure. So we do know this happens once in a while. This could be related to a fan system's not maintaining zones that aren't meeting their cooling requirement. Okay, so this also has a fault too. This is guideline 36 fault, that the mixing air temperature is below the blending of outside air temperature and return air temperature. Recorded 23 fault hours in this, 1.7% of the time. Let's just take a look at this chart. Stuff takes a while to study, have to study the building. It's very daunting. Let's just zoom in on some data here. So we're saying like we have some faults around here. Some of these faults almost seem kind of a little bit silly. So this is saying that the mixing air temperature is less than the outside air temperature and the return air temp. We should also be looking not at fan command. We should be looking at outside air damper command. So let's get to issue here. On temperature related plotting, we need to view air damper percentage, not fan command. Fan command percent plot should only be fault equation 1 for duct static pressure. So this also should be, I just want to demonstrate these are tunable equations. So here's our parameter, mixing tolerance. So I'm going to put this up to 3. Then I think I have to rerun. Go back to fault equation 2. So like the way that this fault equation is written is like, this is a tolerance that the sensors need to be within. And I just want to see if this makes it go away. And there's just like, there's inaccuracies in every sensor. So like what this is just trying to depict is that the, in theory, mechanical engineering theory, the a mixing temperature should always be between the hot and the cold. Reset axis. These are summary statistics. Yeah, I did not see anything really go away. I'm just trying to do some tuning here to see if we can make some of these faults kind of calm down. So like this one, the I don't think this I'm flagging this is like another issue we need to look into, is that the mixing air temperature is 54.06 and the outside air temperature is 54.3. And if I have a 3-degree tolerance, that should have calmed down that fault right here. So okay, so we got some bugs to fix. Sliders not working. Fault equation 2. Let's see, so this was actually, yeah, fault equation 2. So I'll have to build some unit tests. Make a prompt here, please build unit tests. Confirm tuning sliders work. Okay. I'm really not too worried about some of these. It's just well known that outsider temperatures are really inaccurate, and in buildings, and then there's always mixing issues with air handling units, as long as it's not like wildly off. Like this right here is, that's not bad. So that's like 3/100ths, no tenths of a degree Fahrenheit. You know, that's whatever, close enough for me, I think. Um, let's just look at some of these other faults here. Let's see if I go down here. So this left-hand pane will be for tuning rules, which I seem to have an issue. Outsider temperature too warm for free cooling. This is K-stat, or defined by guideline 36. Oh, so we did actually pass. So this did pass. Let's do another one for the outsider temp mismatch, mechanical cooling. What's this one again? Let's look at fault condition 10. So like what, we have lots of faults here. So what guideline 36 does in their fault equations is it defines modes that the air handling unit is operating in based on valve positions and damper positions. So if the air handling unit damper is open in the time series data more than the minimum position, that says that's an economizing mode. If the heating valve is open, that would be a heating mode, and it's so that's guideline 36 has like these different modes of operation that the air handling unit would be in. So this is mismatch in mechanical cooling mode. So this should actually be in economizer plus mechanical cooling mode here. Let me just read this again. So the fault equation is written that the chilled water valve has to be open more than 1%. The economizer has to be open more than 90%, which I can see in the data here. Let me get back to the chart. And then when you're in that mode, that the mixing air temperatures and the supplier temperatures should be pretty much equal. Make sense? So air handling unit would be in 100% outside air mode, and these mixing air temperatures and outside air temperatures should basically equal. This is just another like a fancy, confusing math way to say that they need to be within some tolerance. Okay, let's just go look at the plot again. So this is covering about 2 days, a couple days of data here, and it's showing a confirmed fault that wow, look at this. We should almost be testing this on our PID hunting here, perhaps. Okay, so let's just look at percentage column here. The outside air damper is at 100% open. I find this interesting that this air handling unit must be running 24/7 here, that it's not should also like HU 24/7 June 8th range. Take notes of all this stuff, because if the air handling unit is shutting down, that this outside air damper would go closed at night. Cooling valve does. Maybe that's because the air handling unit catches up. So yeah, you can see something's happening here at around midnight, and then about to 6 a.m. That's when something fires back up. Let's zoom in here. Zoom in a little bit more. Okay, so what we have here, we're not able to drive our mixing air temperature. Actually, our mixing air temperature is way lower than our outside air temperature. Oh boy. Why is the air handling unit in 100% outside air mode? Okay, so June 8th, June 9th, which is not that long ago, air handling unit is in 100% outside air, cooling valve at, so this is where cooling valve and outside air damper 100%, and we're in a fault. We're in a fault because these two sensors should match each other. And I think we know this already, that the previous videos we plotted the outside air temperature sensor reads higher than the mixing air temperature. But what is kind of odd here is that, for one thing, we see this mismatch, but another thing is that this could be a really big mechanical waste of energy going on here. This is gosh, these are just turning into this is going to take like many videos to to run this. Okay, this is, I think we can just look at this RCX plots here real quick. I have to call it a day, and this might be like many days of looking at this. Okay, so like I think we kind of explained this a little bit on the last one, is like fault detection plots and then retro commissioning plots. Retro commissioning plots is the kind of what I used to do in Excel a long time ago, is like you plot all of the zone temp sensors together, you plot all of the air handling unit leaving temp sensors together, that kind of thing. It's just very generic time series charts. So I think I might have a plot. Ooh, this is cool. So this is zone temps filtered for when fan is running. Okay, so we are seeing the fan is shutting down because I am able to filter the zone temp. But what looks really odd in the data is that there's some stuff messed up on here too. What looks really odd in the data is outside air. So let's go to air handling unit. So this is all data model driven. The JSON to haystack like on that JSON mapping, so it maps all of these plots together for you. This is something we also we should have fixed in here too. Is we talked about this yesterday. We haven't even got here today. All outside air dampers. All right, so it looks like the fan is. Yeah, this is just, something just looks incredibly odd here. That the outside air dampers are constantly 100% open. So we have some like very strange things going on. Whoops. In these reports. So like if you remember yesterday, guys, we're just briefly looking at these air handling units. And what I'm seeing is these dampers are 100% open, even when the fan is off. You know, some anomaly is happening in the data. And there is a fault that we looked at today where there's a mismatch between the outside air temperature and the mixing air temperature. And I think that's related to the outside air temperature reading about 5 degrees higher than what you get from the web. So it's my own little theory. We don't have a lot of information to say that, but like kind of is what it is. Yeah, where can we go with this? So like there's either a problem with these mixing dampers not mixing the air, that you should get these outside air temperature sensors to the outside air and mixed temperature should equal each other at 100% outside air. If the dampers are mixing correctly and the sensors are calibrated or somewhat accurate. And there's just a few other odd things that look off in this building. Okay, yeah, there's just tons of stuff. Oh, okay, so I'm just like, this is going to be many videos, but whatever. It's I think it's good for people to make their buildings run better, and you know, the more people that are doing this stuff, you know, educating building operators, service departments, and mechanical contractors, the more that we're fixing HVAC systems, the more that we can reduce our utility bills, you know, that kind of thing, and kind of make the planet a little greenhouse gas reduction friendly. Okay, another thing I wanted to show you guys too is what I have been thinking about for this person is this needs a little bit of updating. So the Niagara for Vibe Code Addict, this is a Niagara platform, and have been thinking about this is like this. I do have pre-built wire sheets for guideline 36 algorithms where this has been tested. I've tested this on about 60 different air handling units. So this is a pre-built wire sheet where the technician link marks and then the algorithms are written in this. This would be to do a duct static pressure reset, cooling requests. So this is known to be working really well. And then also where are we here? So we do have one for APIs. And then I do have a wire sheet for Open Weather Map API. So there's a little bit of Java code inside this Niagara widget that can grab data from Open Weather Map API. And we can also expose that as a Niagara object that you can link to. So the building in theory could control to web weather. If we do find that it is a little bit more accurate than a local one, then if this guy goes stale or something happens, that you can always resort to the local one. And we could also probably include some better economizing logic with factoring in dew point as well. So that's where I'm kind of going with this stuff, guys. So that's all I have for today. This might be like a monster video series here. So fixing some bugs along the way. Thanks for bearing with me. And if time permits, I will plug away at this to just jump straight into where we left off on the last video, because it's getting kind of redundant on each video, kind of covering the same topic, and then pretty soon the videos get too long. So let's I will see you guys on the next go round. Have a good one.